So, hey everyone, it's already 4 p.m. in Central European time. It's time to start our meeting. So, welcome everyone, and I'm so happy you're here to have a friendly chat with our fellow Enhanced STEM ambassadors, talking about STEM studies, doubts, and choices that matter for our future. Today's session is a part of a special webinar series organized in collaboration with the Enhanced University Alliance that brings together 10 universities of technology across Europe and EIT Girls Go STEM initiative. Girls Go STEM is an educational program and European initiative that equips students with digital and entrepreneurial skills and empowers the next generation by promoting equal opportunities. My name is Darina Strynyak, and I am an EIT Girls Go STEM ambassador from Ukraine. And before we dive in, I'm truly excited to moderate this event as I'm very passionate about showing girls and women that they belong in STEM and that their dreams should never be limited by stereotypes. Tonight, we'll hear from inspiring women who prove that with curiosity and courage, science can change the world. Coming back to our panel discussion. And today we'll be talking about how math and physics can help make our world cleaner. It is no secret that nowadays humanity faces a lot of environmental problems caused by massive industrialization and human activities. Our speakers will share their personal paths, express their opinions, and highlight how science can be applied to solve real challenges. So please welcome our first speaker, Kinga Stawiarz, a student of technical physics at Gdańsk in Poland, specializing in applied physics. Welcome, Kinga.
Hello, it's really nice to meet you.
Then we have Filippa Malmgren from Chalmers, Sweden, a student of civil engineering and urban design. How are you, Filippa?
I'm good, thank you. A bit cold as always, but that's the way things are.
Yeah, and finally, Alicia Tsuru, who is an Italian student of applied mathematics at TU Delft in the Netherlands. Welcome, Alice.
Hi, thank you. And hi, everyone.
All right, so now I will explain how our session today will work. So for the next 40 minutes, we're going to have a conversation with our STEM ambassadors, talking about their studies, talking about their researches, and how they can use their subject and their knowledge to solve real environmental problems. And then we are going to open up for a short 15-minute Q&A session. And there are a couple of ways that you can ask your questions to our STEM ambassadors. Firstly, by writing in the chat, I will monitor it and I will use some questions from the chat. Then you can ask the questions directly through your microphone. And of course, there's a link in the chat, Mentimeter. You can use that and write your questions completely anonymously, and we'll ask some questions from that. So there's only one rule today. There are no wrong answers, and today is about being real and sharing our opinions and thoughts. So let's start. So let's start from Kinga, because you're studying technical physics. What first got you interested in this field? Because it's very extraordinary.
Yes, I'm a technical physics student, and actually, I didn't know what to choose when I was in high school, but I saw that physics comes easily for me, and I had an inspiring teacher, so I decided to take an extended course, and then I decided to study this degree.
That's very nice. And what about you, Felipa? You are a student of civil engineering and urban design. These are very interesting combinations. How did you come to this conclusion that you want to study these subjects?
I actually was really sure in high school what I wanted to study. I liked all of the science sort of subjects, but I was less interested in the actual science of it, more of the application in our environment and for people. And I realized that, oh, civil engineering is very directly doing that, but for built structures or housing or even on an urban scale, which is what I'm doing now. And I thought that was super, super thrilling and exciting to work with. And that's how I ended up picking it for my degree.
That's very nice. And as far as I'm concerned, I know that Sweden is known for its futuristic and very creative designs. So what can you say about that? Has Sweden and every sometimes inspires you to continue your walking? What can you say about your home country?
Yeah, it's actually interesting because we've had a lot of case studies on cities and developments in Sweden that I've never thought about, but I've maybe passed a million times in my everyday. So the nice thing about it is that you get to see like your surroundings in a new perspective the more you learn about the tools we've used to build certain types of houses or developments. So I think we do a lot really well in terms of sustainability, but of course there's always things to improve, and that's what you're studying to get better at.
Yeah, thank you so much. And Alicia, I think that applying the mathematics is kind of a hard subject. And how did you decide on your specific major? And has there anywhere been some role models that really inspired you?
Well, okay, so as the other speaker said, I also was not really sure what I wanted to study. I liked mathematics in my high school. I liked physics. So yeah, like it was a difficult choice for me. But eventually, I think that I ended up more towards maths because I think that what I liked the most was like trying to solve puzzles, trying to figure out, I don't know, like solutions. And I think that's the kind of mentality that it's really important then in mathematics. Also, when you are in high school, you think that mathematics is something, and then when you actually study it in university, you find out that it's like a really different subject. That's what you thought it was. And to go for your second question about the role models, I don't think I have like a specific like mathematician role model. Yeah, I think that, I mean, I had like some professors in my high school that were inspiring to me because they were really able to explain the subject in like a clear way, and I think that's really important for this kind of subjects.
Thank you so much. So you have mentioned previously that mathematics in university is somewhat different from high school mathematics. So what surprised you the most about your field? And has there ever been some situations or some stress? And how exactly did you come across it?
Yeah, okay. So it is different in a sense that when you see mathematics in high school, it's mainly like numbers. So you see a lot of numbers, you solve equations maybe with numbers. But then when you actually study mathematics, you understand that it's a little bit deeper in a sense that it's more about understanding and critical thinking and trying to like prove things. And less about numbers. So I'm not good with numbers, for example, but still I study mathematics. So that's something that really surprised me. And another thing that really surprised me that I didn't know about mathematics is how much mathematics is in the word and how everything can be really described with that. So sorry, I also missed the second part of your question. So you were saying...
Yeah, so I actually wanted to ask you about, has there ever been some stress during mathematics and maybe some concepts that were hard to understand? Is this a common practice, among students that are learning STEM subjects? What can you say about this?
Yeah, definitely. I think that everyone at some point struggles with something when studying mathematics, but also like physics or engineering or like every other subject probably. I think, yeah, like this happens, and that's part of the learning also to understand how you can deal with the struggling. But I think that the most important thing when this happens is share the burden with other people around you. So like make friends, and in that way you can yeah, it can be easier for you.
Oh, that's actually really interesting. So, Kinga, technical physics is also a really hard subject like mathematics. What's been the hardest part of your studies?
Oh, I think that what surprised me most was the amount of subject connected with coding and programming, because actually it's pretty connected with maths and also with physics. And to do your project, you need to learn how to code. And like, I didn't have the extended course from informatics in my high school, and I had cried and coded, cried and coded all the time. But actually, at the end, I'm quite good at it. I need still to improve my skills. But when you go to studies connected with mathematics, or even, I think every degree of engineering needs specialists in programming. So that's one of the hardest tasks to do. Not the physics task, but the coding tasks. But everything is like simple to learn, but you just need to face it. Actually, yeah.
Has there ever been any more misconceptions about your subject, Kinga?
Misconceptions. I think that people don't know how much physics is important, and like, it's the basis of nearly every engineering subject. But on my studies, we had so much like theoretical studies from physics. I didn't expect it. Like, I mean, I expected it, but it was harder than I thought, because as Alicia said, you like, you link the numbers with the physics and with the maths, and when you go to the theoretical physics, there's no numbers. It's just the letters, and not normal letters. There are Greek letters. So you also need to learn the Greek alphabet to learn how to write an equation in proper way. So that's what was quite surprising, I think, and tough at the beginning.
Okay, thank you so much. So, Philippa, during your university or maybe pre-university years, has there any like been a person or a group of people that wanted to discourage you from studying STEM, or maybe just generally your major?
I have to say, I think actually it's not really a very clear group of people that are like your opposition. I think depending on the types of classes you're in, it can sometimes even be your own class, because everyone struggles in the beginning and everyone thinks it's very difficult. But no one maybe is open with that, or people don't really say that they're struggling, or they're scared to ask questions because they don't want to look stupid in the class. And I think that after year one, when everyone had gotten to know each other better and everyone had been trying for the same math tests, everyone was like, wait, okay, you all thought this was difficult. So why didn't we just talk about it as a group? So sometimes it feels like you can maybe be your own opposition in that way, or maybe discourage yourself by trying to be better at something than you are. And I mean, I wish I realized earlier that there's, of course, no shame in learning something. You're there to learn and you're a student. I wish I had asked more stupid questions in my first year, because then they can only get worse as you go on, because things will only get harder. So yeah, I think that's a big takeaway that I wish I'd realized earlier, but that I would say I hope everyone can realize way earlier than I did.
So Kinga mentioned before that STEM subjects are really connected. And Philippa, in your work in urban design and civil engineering, how does math and engineering help create cities that are better for people and the environment?
Yeah, great question. It's maybe not so clear to everyone how you use math and physics, but for me, when I first did my civil engineering degree, I really liked the very clear connection you have with your numbers. Whenever you do a calculation, it's always for a building to take this or that load, or it's for a building to be this temperature or have this humidity. And if you get those numbers wrong, you're not going to build a very good building, or maybe not the kind of building people want to be in. And for me, I really like it on a big scale. So on an urban design scale, we do a lot of computational fluid dynamics, for example. So you do modeling where you have these physical flows as a sort of baseline in your code. So you simulate maybe how the water moves if you get a sudden flood, for an example, or you simulate how the wind will move in a city. And when it becomes hotter in the summers and colder winters, you get more temperature differences. And with the world developing as it is, we're only going to get more extreme climates. So it's really important that you have these tools to simulate these sort of scenarios to make sure that when we build our cities in the future, they can handle these sorts of very turbulent conditions. And in order to do that and simulate that in the best way possible, there's really no other way or tool to use than either math, where you do the actual, you take the numbers and you say, this is the limit for what a building needs to handle in terms of added water load, for example, or physics in terms of how much actual wind can we put in this sort of tunneling system before it breaks down, for example, for trains or trams. So that's a really big part of what I do, at least on this scale. And it's very nice. You get very direct consequences if you do it well.
So what can you say about solving, like talking about the concept of environmental problems and how is it affecting our cities nowadays? And how can you use urban design and civil engineering in order to help our cities be more sustainable?
Yeah, so for example, in some areas in Sweden, the work that I'm doing now is very focused on these industrial areas where you used to have maybe production or manufacturing in the cities, but now more and more people are moving into the cities. So by 2050, I think around 70% of the world's population are going to live in cities. So it means we have to turn all these areas into housing, and we have to make sure that they are stable for housing in roughly 30 years. But added to that issue, like I mentioned earlier, are these extreme weather changes where we get more rain, we get hotter temperatures, etc. And sustainability in this case means that we need to not only handle that environmental load in these new areas that we're building to make sure we can handle just the weather itself, but also to make sure that we can handle the people moving in, because you can't have some parts of it flooding while others are dry, for an example. So sustainability in this case is both about meeting climate demand, but also how do we do it for humans, which is a nice puzzle to solve, and it's a big part of the urban design sort of core itself.
That's very interesting. Thank you, Filipa. So, Alicia, mathematics is kind of being known for being abstract. What can you say about this, and how can you exactly use math to solve real challenges?
I think that when you study mathematics, you can make it as abstract as you want it to be, in a sense that you're gonna choose what you want to work on. So if you want to go with like really pure mathematics, then you can do that. If you want to go in a little bit more applied things, so for example, development of algorithms, then you can do that. But then you can also go with things a little bit more, even more applied, such as applying, like using statistics and applying models for like real world problems. So also Filipa was mentioning before that we can, for example, regarding to floods. So with mathematics, you can actually predict using the historical data, so data from the past, when a flood can happen. And this is really important. So mathematics can actually be used for this, so like to predict things that will happen based on what you know from the past, so from data of the past. Then you can learn patterns with mathematics in the same way, and also you can test solutions in order that you don't have to waste resources or time, and just can simulate through mathematical tools in a way.
So have you done maybe some researches or some projects that when you are directly like talking, thinking, and investigating about real climate changes and maybe about environmental problems, and how can you like kind of include math in it? have you done some maybe examples and researches?
Yeah, so well, I'm doing my master thesis now, and the main topic is an energy planning systems. So when you're planning where to invest on, you need to make sure that you meet demand in the future. So in particular, you need to be sure that you will meet the demand like now, in 10 days, in 10 years, in 20 years. So you can imagine that this become like a really big problem. In the same way, when you include renewable energies, you don't know a lot about how they will, like how much energy can be produced from them in the future. So, for example, you don't know how much wind will blow or if the sun will shine in every day. But then you can use mathematical tools to make a sort of prediction of how this will happen. And then you can use optimization tools in order to find a solution when I say a solution is understanding how much you need to invest on this technology, on these energy technologies, etc. So you can use mathematics for this, and that's of course like I'm doing a little part of this big project, but yeah, that's what my project is about. It's basically when you have like this big problem, how can you solve it in a smaller scale in order to have actually a solution?
Oh, that's amazing. Thank you so much. So right now, I just want to remind you guys that you can write your questions and you can use Mentimeter if there's a link in the chat if you want to address your questions completely anonymously. And then we'll have at the end of this session a short Q&A session. So coming back to you, Kinga. So how does your work directly and specifically physics contribute to making the world cleaner and more sustainable?
Actually, I would like to tell you a little bit about the research that I'm doing, because physics plays a significant role in making the world cleaner. Right now, I'm a researcher at Institute of Oceanology in Poland, and I am investigating the microplastic contamination in the air and in the surface and deep waters. Actually, microplastics are small particles. Small, I mean less than 5 millimeters, which are present in nearly every natural compartments and even our human bodies. So that's an extreme global issue which was created because of decades of using the plastic. And right now, we are just monitoring how this contamination is changing. Where is it higher? Where is it lower? How it looks like in the middle of the city? How does it look like? How does it look like at coastal areas where the exchange with the wind exchange is much bigger, and we are trying to do a statistic from it.
So what can you say right now based on your statistics? How bad is the problem of microplastic is nowadays?
I think it's hard to tell how bad is it, but we can definitely say that they are present actually in in the air and in the products. When you, for example, buy some products, you need to take care how they are actually packed, because as we buy the vegetables, they are also packed in the plastic when we buy them from supermarkets. And also there was a nice research about the milk for the children, and this instant milk is packed in a cane which is lined with plastics inside, and also it has a plastic top, and the I forgot the word. Sorry, łyżeczka? The spoon. Sorry, the spoon. So everything is actually made of plastics, what makes it really, really bad when we analyze these materials. So we can say that they are present, and we need to check how is it in our natural compartments.
So have you done any interesting expeditions, any interesting researches, and how can you integrate physics in your researches?
This year, I was on Arctics, where I investigated the air-sea transport. So we tried to see if there is any way that the microplastics from the sea can be absorbed to the air, and how is it like doing the far-reaching transport of the microplastics. So that was the most interesting thing that I had experienced because it was in a rough conditions actually. It was on a ship, on a research ship. So I have spent there 2 weeks like to try to see if there are any microplastics in the surface waters. I can show you some photos in my background. That's me trying to see if there are any microplastics in the deep waters. And also that's the net which we use to grab the microplastics from the surface waters. So that's our apparature that we use. We also use the aspirators to see if there are any changes in the air as we sampled it.
That's actually very interesting. Thank you so much, Kinga. So coming back to you, Felipa, what can you say? Is there like any underrated solutions that can actually help make our cities cleaner and greener?
I'm gonna say the horrible answer. It depends, just because it's truly such a layered issue. And when it comes to sustainability, a lot of the times people chalk it up to, for example, the percentage of green space areas in your vicinity. So since COVID, I think it was TU Delft researchers actually who came up with this rule that you need a certain percentage of green space within 300 meters from your apartment, for an example. And that's what people most often look at sustainability. But at least for me, or the research that I've been doing is a lot about scenario planning. So if you look at 50 years in the future, what you build today should still be sustainable then, and even further than that, because the technical lifespan of a building or an infrastructure system is so long, it's going to outlive the people who are building and drawing it. So it basically means that you always have to have this long-term perspective. And I think that can sometimes maybe be underrated, that politicians or investors don't always maybe see it the same way. If you look at maybe developing certain areas for commercial use, for example. So it's always very important to have that in mind. And a big part of what we do is trying to visualize that. So what are the costs if we don't do this as sustainably as possible for the future? And that's where, like both Alicia and Kinga has mentioned, that's where physics and math comes in. So a lot of the times it's the best way to sort of make that long-term perspective really clear and put that into things, into versions people understand. So numbers or costs. So yeah.
Well, that's very interesting. And talking about future, like what can you see about cities in like 10/20 years? How do you think they will evolve?
One really interesting trend that's been happening, at least in Europe, is, I mean, there's a lot of a big proportion of people who are young, educated workers moving into cities, and it's getting harder and harder to find housing. So we're seeing a lot of new forms of housing, like mixed developments and co-op, where you live and share a lot of facilities. And some of those have become sort of super blocks, is what they're called, when you start planning around living and sharing maybe tools or, for an example, bigger amenities in a very, very communal way. So that's one trend that's becoming increasingly sustainable from a social perspective. I would also say that I think the development of more just green spaces has been really interesting, where people look at green nodes. So if you look at a city map and you isolate just the green areas, they should all be in different axes. So you can follow them sort of. If you move through the city, you should always be able to stumble across a park or something similar that breaks up this very gridded sort of infrastructure. And I think those two trends sort of are pointing towards a kind of exciting future going forward in what we're building. And I think it's exciting to look at it as well in my studies.
So what are the most specific examples that you love about sustainable urban design?
Specific examples can be a bit difficult. I think it's oftentimes it's when we look at new kinds of flagship buildings that are very unique and one of the kind. So we have an example in Sweden. I think it's one of our northern cities. They've built quite a large or a taller building that just made out of timber entirely. So not a skyscraper, but a high rise, you could say. And if you look at any sort of timber building, it's a lot more sustainable generally for the environment than looking at a concrete alternative. And the fact that they've managed to sort of start stacking it that height-wise and doing these sorts of new systems climate-wise that work with that, I think is really, really interesting. And to have it close to home as well is always nice to learn from.
Oh, that's very nice. Thank you so much, Filipa. So, Alice, what can you say about your research? If hypothetically your research is being used by governments or companies, what would real world impact be?
Okay, yeah, I can say a little bit about it. Also, of course, I repeat again, of course, what I'm doing is just a little part of like a big project. And so I can talk about what is the aim in this setting of the big project. So of course, so what we are doing is trying to like have a prediction of well, we have to find a solution of where we have to invest and in what technology we have to invest in order to to have demand, to meet demand in the future, but still minimize cost right now. What's important about this is that when you do a lot of studies with renewable technology, renewable energies, then you are taking into account the risk that comes with it. And so when you work with them and you find solution to in situations in which there are these renewable energies, then it's also probably more likely that government companies and who will use these models that are being developed will choose to invest also in this kind of energies. And the more research is done on these renewable energies and in solutions that make sure that even if they are unpredictable, you will be able to meet demand. So the more studies are done in this way, the more people will feel less intimidating by these renewable energies. So also for an environment point of view, maybe there will be more companies investing in those kind of energies instead of the conventional energies.
Amazing. And coming back to your studies, you're currently studying at TU Delft in the Netherlands. However, you were born in Italy. What can you say about studying not in your home country? And has it ever been a challenge for you?
I think that studying in a different country is tough. I'm not gonna say that it's easy because yeah, maybe like some people say, yeah, let's go abroad and everything will be fine. Yeah, everything will be fine probably, but still it's not easy to be in another part when you're alone and all your friends are in another state and you don't speak the language of the state you're in. So that's not easy. On the other side, I would say that from my point of view, studying abroad really changes your perspectives. And in my personal opinion, it really made me grow. it made me understand a lot more things about me that I didn't know. So it's ups and downs, as I said before. But yeah, like going back, I would choose this again. But I don't want to say that like it's everything is perfect.
So, are there any advices for students considering international study?
My advice is make a lot of research about not only the university that you're gonna study in, but also the country that you're gonna live in, because you're not only gonna learn new things, study new things in the university, but you're also gonna live and in the new country. So make a lot of research and see if the country that you want to go to aligns with you in many things. So for example, for me in the Netherlands, I feel close to the people from the Netherlands from some point of view. So I can see myself living here. But I think that's an important thing. So not only look at the university, but also look at the whole state and the city where you're going to be living in.
Thank you so much, Alicia. So our Q&A session is coming, and I want to politely remind everyone that you can ask your questions to our speakers, and there's a link in the chat to a Mentimeter where you can ask your questions completely anonymously. Or you can do that by just writing in the chat or just speaking in the microphone. So Kinga, what are your thoughts on the theme of like high school students, more specifically girls, wanting to study STEM? What can you recommend them?
I think that my advice would be firstly to do what you're really interested the most, and nothing comes easily, but when you're passionate about it and when you try, then I'm sure that you will find your suitable career path. I would say that it's important to remember that your ideas can also change during your studies, especially when you're in high school. You have so many perspectives. You can be also easily influenced by some inspiring people that you can reach out. So I'm sure that as long as you do what you love, what you're passionate about and interested in, and you have the curiosity to do it, then just you'll find your way, and don't doubt yourself. It's enough just to have the courage.
That's great. So what can you say exactly about STEM subjects and STEM major? Why should right now teenagers consider this an option? And do you think that there will be a lot of opportunities in the future for STEM fields?
I think that STEM is enrolling so fast that we will need more and more specialists in many fields, like also in these basic fields, like knowing the basis of math and physics, and also the specialists in some more specific topics. In my opinion, the most important thing is to build a good team in the future, and remember that by joining our strengths, we can just do something amazing and something that will be sustainable and something that will be there for years. So that's my perspective, that doing a team is the most important thing.
That's very inspiring, Kinga. So, Philippa, what can you, if you can rewind time, what would you say to your teenage self about studying STEM?
I would need Kinga's pep talk probably for sure. But honestly, it's I've always had really we always had really good role models in terms of having lots of women teachers in STEM and mathematics in my high school. So I think I had quite a positive environment in high school when it came to being encouraged. And I was still maybe sometimes in situations where if I didn't succeed at first, through whatever I was doing, if I was just studying like usual and things didn't come to me, and I felt like, oh, this is never gonna work, I would put myself down too much, like I was supposed to know everything from the beginning. And I think that it's a bad habit that maybe girls can have, especially sometimes, where you feel like, oh, if I just work harder, I'll be able to do this better. And then maybe it's on me to learn this because I just need extra time, etc. And I wish I could tell myself, like, you should never be the first person to tell yourself no. Like, so don't let that be your own sort of advice to yourself. And keep that mindset sort of early. It's always better to try and learn something, and then either you're gonna learn it and maybe not think it's funny, then just be like, oh, funny, I mean fun as in engaging, than just looking at it and being like, no, it's maybe not for me. I'm just not gonna like spend the time. I'm gonna give up on this. So I think that would be my advice to myself.
Thank you so much, Felipa. That's actually very nice and kind. So in approximately 5 minutes, we're going to have our Q&A session. And if you're writing questions, if you want to ask question to our specific speaker, you need to mention that, or you can just use your question to general discussion. So Felipa, what can you say about your studies and what's been the funniest part of your studies that you love? Why you fell in love with civil engineering, urban design, and STEM generally?
I think it's because I was as a very young kid, I played a lot of The Sims, and this is what I'm doing now is like The Sims times 1,000, but you also get to have all of the details of it. So I think it's really, really satisfying when you reach the end of a project and you can visualize it in one way, but you can also talk in detail about what it would mean. So it would require this and this much energy per year, for an example, or you save this and this much operational costs because you choose this sort of building, because the design of the building and the physics that means for the building itself is very tightly intertwined, and I get to have fun in both visualizing it and doing the math, so it works and you can see it in how it works. I think that delivering, when you get to present a lot of what we do, are projects that we present to actual civil engineers or city planners or building physicists that come in and do construction specifically. And it's so fun to get to hear their feedback on how our work compares to what they're doing in real life, sort of outside the campus. So I think that's, for me, has been really rewarding to get that feedback and learn from it.
Amazing, Felipa. So, Alice, talking about mathematics and studying in university, what do you wish someone had told you before you started studying STEM in university?
I think I will I will connect to what also Felipa was talking about before, which is during my first semester of university, I felt that like the topics that I was studying were really difficult. Maybe like my preparation was not enough, so I had to study harder than other people. And what I wish I knew in that moment is that I'm not the only one struggling. And if the people around you, like if the people in your class are saying, for example, that the exercises are easy, then that's because they're only doing the easy exercises. Not because you are the only person who don't get the exercises. So, and that's something that I learned with time, like after this semester, when I actually understood, okay, I can do this, okay. Yeah, so I think that me, 18 years old, that was like in a new place, studying a lot of things. I wish I had known. Yeah, you're not the only one struggling. Yeah.
Yeah, so talking about challenges and hard times, what motivates you to keep going even when the work gets hard?
I think that, well, okay, there are many things that I think can build up the motivation. Definitely one of the motivation is the idea of, okay, what's gonna happen next, so that I'm gonna like, if I study hard now, then I'm gonna have a job that I am passionate about. So that's something that really, of course, motivates me. But I think, as I was saying before, that to go through the university when you're studying difficult subjects is really, really, really important, that you have friends in your in your class, because it's different to having to, like, um, understand everything by yourself, or being with people that understand what you're going through, and they can help you. You can help each other. So, for example, I was lucky enough to meet um, some people in my bachelor at the beginning, and studying with them, learning with them, it's definitely something that really, really motivated me in my journey. Yes.
Thank you so much, Alicia. So I think it's time to open our Q&A session. So you can just raise your hands, write your questions in the chat, and yeah, we have Mentimeter here. So our speakers, what can you think about advices which you give to high schoolers to explore various career paths? Who wants to answer this question?
I can answer this question.
Yeah,
Actually, when I was in high school, I joined many programs which were local. It was called, it was a project for not only for girls, it was for everyone. They were choosing the participants from our school and then getting them to the universities nearby to learn some new opportunities. So I took the courses connected with physics, but there were many of them like connected with English and with mathematics and with engineering. So sometimes when you just reach out, you can find something for yourself.
that's amazing. So let's hop into our next question. Would you please, Melly? How do you, yeah, it's in the chat. So how do you see that AI will impact your area of expertise? What do you think about when selecting a way forward to increase future employability? Oh, that's an interesting question. So who wants to answer this?
I can say something about this. I think that I wish we knew now what's gonna happen in the future. Also because I mean, many years ago, when we were when people were thinking about the future, then they will think about cars that can fly, rather than avatars that can be generated by AI and can talk, right? So I wish we had an answer for that. But in my point of view, I think that AI can well, we have seen that AI has a really big power to predict some things, but then there has to be someone to validate these answers, and there has to be someone also. So, for example, my field is about optimization. So it's about what you can do, what you can optimize after you have already maybe some predictions. So I think it's, yeah, like, I don't know, maybe I don't know if I'm answering to this question, because it's a really difficult question to answer to. But it's, yeah, my field, for example, optimization is a little bit a way of using AI, yeah, in it, like using outputs of AI also.
Thank you, Alicia, for your opinion. So let's hop into our third question. So how much consideration to future labor market did you take when selecting your field of study, or did you approach this more based on passion?
Yeah, I guess I can go. I picked my major initially because I thought it sounded very, very interesting. But then of course I have to be like very honest. When I graduated from my first civil engineering degree, I faced a labor market where you weren't building a lot of things because of the economy. So construction wasn't at an all-time high. And I was lucky enough to have, the energy to keep going in school. I wanted to keep studying, but I think that in the end, you should first and foremost always look at what you actually think is fun, because studying is not going to be easy, and it's definitely not going to be easy if you also don't really like what you're doing. So I think that's a primary consideration to make, because it took me maybe a year to start finding the things I really, really liked in my major. And then as I went along, I found more specializations that I felt was really, really fun to keep reading about. And that's kept me going. And I think that sometimes maybe later on, it's more relevant to look at, can you find a way to connect those passions to something you can do for work? Like Alicia said, like what motivates her is that if she works at this, she can get maybe a job in something she's really passionate about. But I think that connection is something you can always make maybe a few years into a degree where you know that you've already sort of ended up in an area you like.
That's amazing, Felipa. So let's look at our next question today. So how do you deal with women underrepresentation at your university in your STEM field? Do you have a supportive environment at your university? So Kinga, what do you think about this question? Would you like to answer?
I can try to answer. It's actually a tough question because the representation is actually global. There is not much women engineers, but when you find your one woman engineering friend, then everything is easier on the studies. And I can say that I have the support on my university. I have really good friends, and also I have people that I can turn to when I have a problem. So everyone is actually supportive, and it's changing. So now I think it's easier to obtain this way to do the engineering that it was like 20 years ago. So we've made a big step forward.
Yeah, having people who support you is really crucial. So the next question is, how did you get to know your field of study, and did you have a clear view on the study and the jobs linked to it before you started? So who wants to answer this question?
I can answer.
Yeah.
I can say that I definitely didn't know what were the jobs of mathematics before actually studying mathematics. I think that when you're in high school, you don't really like it's difficult to also make a choice that will impact your future self after 10 years. So I chose my field of study because I liked mathematics and I liked what I was doing in high school. But of course, I didn't have. I also don't have it clear right now what I'm gonna do next year. So this year I will be graduating with my master, and there are many things that I could be doing as a mathematician. But I don't know exactly where I'm gonna end up. So I don't think you need to have like this really precise view. And I got to know my field of study through, well, of course, mathematics. You study that in high school, so you know it by that. But also, there are many, as Kinga also was saying, there are many opportunities in high school to, at least I had opportunities in high school to, I don't know, like make some. Be present at some lectures in some universities, or I don't know, talk with also professor who study that subject so that you can have a better idea of the field of study.
That's interesting, Alicia. So let's see another sixth question. And yeah, looking ahead, what type of work would you feel the most fulfilling for you after finishing your studies?
Yeah, now I know we've been answering one question each, but maybe we could do short answers, all of us, for this question, because I feel like it would be interesting. At least in my case, I think I like being sort of the spider in the web. I've realized to do the sort of, you tie together the engineering side with the project side and the design side. So I think doing that on an urban scale and infrastructural scale would be really, really interesting. And doing it abroad, of course, would be fantastic. Like Alicia mentioned, it's really, really nice to go abroad, and you learn a lot about yourself. So and there's also bigger projects. So for me, that would be it.
I can also say about me. So in my opinion, okay, I definitely know that I want to work with optimization, like applying mathematics. And if I think about what would be more the most fulfilling to me, is applying mathematics in a subject that matters. So, for example, working, like as I was saying before, with optimization in the energy systems, that is something that I see that can have an impact in the world, and that will be really fulfilling for me. But there are many other ways in using mathematics that can be like really fulfilling. So, for example, I know that there is this project where they use optimization to understand how to optimize the distribution of a humanitarian aid. And like working on something like this will be really, really something that maybe a dream that that I can have. Yeah.
I really love both of your ideas and keep my fingers crossed. My idea is to continue studying on medical physics degree and start working in a hospital as a medical physicist. And also, I was thinking about doing a PhD connected with microplastic, but linked to human body exposure. So that will be like the most ambitious plan, but I think that I would be really fulfilled, and we will see what happens.
Thank you so much for your opinions, and I think that it is really great and it's very cool that you consider to work in STEM fields, not just to study them in university. So what should students focus on besides technical skills? So maybe Filippa, you can talk about that. Oh, Kinga, I saw that you wanted to answer that, so go ahead.
Go for it.
Okay, I think everyone of us can say some advice, but I think English it's really important because that's how you can communicate easily and build a international team. It's also very important to work as a researcher and also as a person in engineering.
Yeah, I agree. I was gonna say maybe like soft skills like communication. And I think it always helps to know, there's one thing to know, it's one thing to know your material, it's another thing to present it and make other people know it or not know it. And it's really helpful to just feel like you have a really good toolbox for group projects or presentations and feel comfortable in those situations, because you're always going to have more and more things to present for more and more senior people. And I think looking into that, if you know you're nervous or maybe you don't really like public speaking, that's always a skill you can work on. So I think that's one thing that's always going to be beneficial.
Yeah, thank you so much, Filipa. So our today's session is coming to an end. There are 2 minutes left, and I think that we can like kind of close our session for this 2 minutes. So maybe girls, you could like each say one sentence of advice to like girls considering STEM. So maybe we can start from Kinga, and then each one of you can share their thoughts, like in just a couple of words, because we're short on time.
Could you please repeat your question? Because I got distracted.
No worries, Kinga. So I was asking about like one sentence of advice for girls considering STEM. Maybe something really like inspiring that you can say.
I think that don't be scared. Just, but being scared is okay, but just take the opportunity, and I keep my fingers crossed, and I know that you will do it. Yes.
Yeah, what I can say is find your support network. That's what it will help you through your difficult moments that you're gonna have.
Yeah, I'll do a basketball quote sort of that I always use in my head. It's you miss 100% of shots you don't take. And it's so cliche, but it's really true. I think go for it if you're even slightly curious in something, and then let that inform if you want to pursue it or not, instead of trying to talk yourself out of anything from the beginning.
Yeah, so thank you so much. And before we go, I want to remind you that this is just one session in our special webinar series. So there are more incredible conversations coming with our fellows Enhanced STEM ambassadors. So if you want, you can register. There's a link, and there are going to be some great topics out there. So I think you should definitely try that. And thank you everyone for coming to today's question, for being here, for asking thoughtful questions, and for being curious about STEM. And Kinga, Filipa, Alice, thank you so much for being so open, so honest, and so inspiring today. And finally, a huge thank you to our organizers, Enhanced Alliance and EIT Girls Go STEM Initiative. Regarding Girls Go STEM, there's a site where you can find different courses in a lot of languages like English, Polish, Ukrainian, and many more. So you can visit that. There's so much opportunities for girls that want to learn STEM. And it's already our time. Thank you for your thank you everyone in the chat for writing so warm words. Thank you so much everyone for coming, and see you later. Goodbye everyone.
Thank you, everyone.
Yeah, thank you. And thank you, Darina, for a good session.